Reality has rules. Yet every so often, Earth produces an event so bizarre, so apparently impossible, that our pattern-seeking brains whisper, "The simulation just glitched." Imagine this. A bolt of lightning freezes in midair, not metaphorically, visually. A branching tree of electricity hanging motionless over a highway, while cars continue to move underneath. Videos like this spread online with captions like, "Lightning glitch in the Matrix." In reality, it's usually a rolling shutter effect from a phone camera scanning the scene line by line, but the feeling it triggers is real. The sense that the underlying code of the world just hiccuped. Or picture a murmur of starlings, 100,000 birds moving as one fluid organism. Sharp turns, expanding rings, sudden holes in the flock that open and close like an invisible object is passing through. To the unaided eye, it looks like physics forgot to enforce individual free will. Our brains try to pass each bird's path and fail, so the whole thing feels like a rendering bug in reality. Then there are rocks that move, with no one there to push them. On a dry lake bed in Death Valley, stones weighing tens of kilograms leave long, graceful tracks in the mud, as if someone dragged them in the night, then erased their footprints. For decades, no one had seen them move, just the before and after. The implication, in the quiet dark, something about the rules changes. We also see circles where we don't expect them. Passengers on planes sometimes look down and see the aircraft's shadow perfectly encircled by a glowing rainbow halo, hovering on the clouds below. It looks uncannily like a selection highlight in a video game. Reality choosing an object. No arc like a normal rainbow, just a precise ring of color centered on you, following you. And sometimes entire landscapes seem to drop their texture resolution. Fog banks that appear out of empty air in sharp, straight-edged walls. Highways where visibility goes from clear to opaque in a single car length, like driving into a bad render distance. People describe it as the world loading in late, as if the environment engine is struggling to keep up. Then there are the ocean waves that move too slowly. Rogue videos show waves that look like someone set the world to half speed. Smooth, glassy walls of water seeming to hang, barely advancing, as surfers glide along them. To some viewers, it's like time itself stuttered, as though the simulation dropped a few frames but kept the soundtrack going. Even in more controlled environments, we see things that seem to ignore the rules. Legendary mystery spots where balls roll uphill, water appears to defy gravity, and pendulums swing in skewed directions. Visitors walk through tilted rooms and feel their bodies pulled sideways by an invisible force. They watch objects behave as if gravity direction were quietly edited by a game developer experimenting with settings. Or the sky will briefly act like an over-enthusiastic particle engine. Meteor storms where dozens of fireballs streak overhead in minutes. Collides that explode with the energy of nuclear weapons high in the atmosphere, turning the night briefly brighter than day, casting hard shadows, then vanishing without a crater. These are real events, but they trigger an ancient suspicion that the skybox above us is not as stable as it looks. So what exactly do people mean when they call these glitches in the Matrix? The phrase comes from the film The Matrix, where déjà vu, a repeated moment, is a literal error in a simulated reality. In our world, we borrow that language for natural events that feel like bugs in the source code, highly improbable, visually contradictory, or simply outside our intuitive model of how Earth is supposed to behave. Psychologically, a glitch is what happens when our brain's internal physics engine collides with the real universe and loses. Your brain is constantly predicting what the next fraction of a second should look like. When reality delivers something that violates that prediction, like lightning that seems frozen, water that looks like it's flowing uphill, or birds moving as a four-dimensional object, the result is a brief sensation that the world is wrong, not just surprising. Technology amplifies this feeling. Our cameras don't sample reality the way our eyes do. Phone sensors read scenes line by line at fixed frame rates, with limited dynamic range. Under fast or extreme conditions, lightning, propellers, spinning fans, they produce distortions, bent blades, segmented bolts, objects apparently teleporting between frames. When we watch these clips, we're seeing not just the world, but an interaction between physical reality and the quirks of our senses, a place where the rendering pipeline itself leaves artifacts. But not all glitches are camera tricks. Many are genuine emergent behaviors from complex systems that happen to look like bugs. Take those starling murmurations. Each bird obeys simple rules. Match your neighbor's speed, avoid crowding, steer toward the average direction of those nearby. This is called a self-organized critical system. From millions of local decisions, a global pattern emerges that no single bird understands. To our eyes, that pattern feels pre-computed, as if some hidden intelligence is rendering the whole scene at once. The moving rocks of Death Valley, also called sailing stones, turned out to be a collaboration between wind, water, and ice. In winter, thin sheets of ice form under a shallow film of water. As the morning sun warms the surface, the ice breaks into floating panels with rocks embedded in them. Even a gentle breeze of a few meters per second can push these ice rafts, and the rocks carve trails in the soft mud below. The motion is slow, maybe a few centimeters per second, too slow for the human eye to notice casually. So we see the tracks, never the process, and our brains file it under impossible movement. That rainbow halo around a plane's shadow, it's called a glory. It isn't a supernatural highlight, it's optics. Sunlight hits tiny spherical water droplets in the cloud and undergoes complex scattering, specifically Mie scattering, which depends sensitively on droplet size and angle. Some light is reflected backward, interferes with itself, and forms concentric rings of color centered exactly on the line between you, the droplet, and the sun. Every observer sees their own personal glory, always centered on their own shadow. It feels like the world is tagging you, but really you're just sitting at the focus of a geometry problem. Fog walls? That's fluid dynamics plus phase transitions. When warm, moist air slides over a cooler surface, like cold ocean water or a chilled valley floor, it can reach its dew point, the temperature where air can no longer hold all its water vapor. Microscopic droplets condense, and air that was transparent becomes opaque in a matter of meters, because the underlying temperature gradient can be sharply defined, say, where a cold current meets a warm one. The boundary of the fog can also be incredibly sharp. Driving into it feels like crossing a loading boundary in a game, but what you're really crossing is an isotherm, a line of equal temperature. Those slow waves are about relative motion and human perception. A wave's speed depends on wavelength and water depth. In deep water, long wavelength swells can travel at 40 to 60 kilometers per hour. But near shore, as the bottom shallows, the wave slows and grows taller. Surfers move along the wave face at nearly the same horizontal speed as the breaking crest, so relative to them, the wave appears almost stationary. When filmed from another moving platform, like a boat pacing beside the surface, the whole system's motion can line up so neatly that the wave's forward progress nearly cancels out in the frame. Time isn't slowing, your reference frames are just cleverly aligned. Mystery spots and gravity hills play a different trick. They hack your internal level sensor. Your brain estimates level by combining visual cues, like walls, trees, and horizons, with signals from your inner ear. If you're placed in a carefully constructed environment where all visible references are tilted, buildings, fences, even the slope of nearby terrain, a mile downhill can look like uphill. When a ball rolls up, your eyes insist gravity is broken while your vestibular system quietly screams that everything is fine. The conflict feels so wrong that we reach for language about glitches, as if someone misset the gravity vector in the physics engine. So why do we keep reaching for simulation metaphors to describe these moments? Partly because, for the first time in history, billions of people have daily experience with artificial worlds, video games, rendered movies, virtual reality. We know what actual bugs look like: clipping, lag, objects popping in and out, and we've trained our pattern matching machinery on them. When we see something in nature that even vaguely rhymes with those behaviors, the Matrix glitch label is irresistibly convenient. But there's a deeper, more unsettling reason. These events expose the gap between our intuitive physics, the rough evolved model in our brains, and the underlying physics, which is often non-linear, probabilistic, and full of threshold effects. A glitch is not a failure of the universe, it's a failure of our expectations. The world was always allowed to do that. We just hadn't updated the code in our heads yet. And if these surface-level oddities already feel like cracks in reality, they are nothing compared to what we find when we push past intuition and start asking whether the rules of the universe themselves are as solid as they appear.